to take a look at two examples. The first example is going to be very straightforward, where all of our givens are provided to us in the units that we expect. And then an example number 2, where we're going to have to do a gram to mole or a mole to gram conversion. This will be very similar to the mile markers that you will be taking for PV equals nRT. So if we take a look at the ideal gas law, we're going to be looking at all of the different letters, the variables, P, V, and R and T. The first is pressure, which must always be in ATM, and typically it is provided to you in that unit. The next one is volume, which must be in liters. Sometimes it's given to us in milliliters, and we need to convert by moving the decimal 3 places to the left. The next is N, which represents the number of moles of gas. Sometimes it's given to us in moles, but sometimes we're given grams, and we have to do a gram to mole conversion. R is a universal gas constant. It will be the same every single time you do this equation. We'll talk about what that R value means shortly. And finally, T is temperature. Temperature must always be converted into Kelvin. Typically, we're given temperature in degrees Celsius, and we're going to add 273.0 to that value to make sure we have the correct units. So let's review and make sure that we've got our units in our head. So first of all, pressure must always be in atmospheres. Next, volume must always be in liters. Next, temperature must always be in Kelvin. All right, so we're going to go ahead and take a look at this first example problem. And the first thing we want to do is walk through and identify all of our variables. So it says the average lung capacity of humans is about 4.0 liters. Assuming you are breathing pure oxygen, how many moles of oxygen gas can your lungs hold at 37 degrees Celsius, which is about body temperature, and 0.97 atmospheres? So the first thing I'd like for you to tell me is, what is the pressure? The pressure is 0.97 ATM. Next variable we need to identify. What is the volume? It is 4.0 liters. And finally, what is the temperature? 37.0 degrees Celsius. So now we're going to head and solve this problem. I'm going to list my pressure, my volume, and my temperature. I'm also going to list my value for R, which we referred to before. This value for R is a constant, which means it's the same every single time. And finally, my unknown is how many moles, or the letter N. So what we're going to do is we're going to back out of this, and I'm going to go over into the whiteboard here, and we're going to take a look at solving this problem as if we were in class. So we already said that our pressure is 0.97 ATM. Our volume is 4.0 liters. Our N is our unknown. Again, they asked us how many moles do we have. R is always the same value every single time, 0.0821. Liter atmospheres on the top, mole Kelvin on the bottom. Yes, there are 4 units. Yes, you do need to write them every time, but you're going to see the beauty of why it's written that way and how that helps us to get to our final answer that we need. And finally, our temperature is 37.0 degrees Celsius. Now, in terms of our units, that's ATM. Our pressure is totally fine. Volume is totally fine, but my temperature here is 37 degrees Celsius. So I'm going to need to add 273 Kelvin to that in order to convert it into Kelvin. So 273 plus 37.0, and you can assume that there are lots of sig figs after 273, so you can assume it's 273.0. So I add this up, 7 and 3 is 10. Carry my 1, 11, I have 310 Kelvin. You could even put 0.0. I'm going to set up my equation, PV equals nRT. My goal here is to get to moles. Moles is the letter N. We need to see this step every time you set up an ideal gas law. In order to get N by itself, I'm going to need to divide through by R and T. And whatever I do to one side, of course, I'm going to do to the other side. My R and T cancel here. So I finally have N, the number of moles, is equal to PV over R times T. Now I'm going to go ahead and substitute this in. My pressure is 0.97 atm. My volume is 4.0 liters. Notice how I'm adding the units in every single time I do this. My R is 0.0821. Again, liters, atmospheres, mole, Kelvin. I'm going to write this every single time. And finally, my temperature is 310.0 Kelvin. Okay. If I've done everything correctly, my unit should cancel except for the unit that I want. Remember, our goal is to get to moles. Atmospheres cancel. My liters cancel. My Kelvin cancels. The only thing I have left is moles. And moles is technically 1 over 1 over mole. So it's like the mole does a forward flip, and we end up with moles in the numerator. So now, in terms of my calculator, what I want to put in is 0.97, the 4.0, the 0.0821, and the 310.0. These are all the values that I need to put into my calculator. In my calculator, which is a very important part of getting your mile marker correctly, I need to show that I can get the correct answer. I'm going to say 0.97, and I'm going to say times 4.0 because they're both in the numerator. Everything in the denominator needs to be divided by. So divided by 0.0821 and then divided by 310.0. This is the fastest way to get to your answer in the calculator. But you can also go ahead and do it this way. 0.97 times 4.0. You can say divided by and then put in parentheses 0.0821 times 310.0. Now, this is an extra step and not really a necessary one, but if it makes more sense to you, remember the division sign distributes across the parentheses, so I'm really doing it the exact same way I did it the very first time. When I put this into my calculator, what I get as an answer is 0.15244, and it keeps on going. But remember, if we look at all the values given to us, we had 2 sig figs, 3 sig figs, and 2 sig figs. We always round to the least number, which is 2. So I'm going to underline my first 2 significant digits. The 2 tells me to round down. So my final answer for the number of moles is going to be 0.15 moles. And this is the final answer to this question. Let's go ahead and take a look at the second gas law example, which will be very similar to the type of question you'll have on your mile marker, and that will be the second question. So they said, what is the volume that is occupied by 2.34 grams of carbon dioxide gas at 0.988 atmospheres and 25 degrees Celsius? So let's go through and first identify our variables. What is the pressure given to us? Yes, the pressure is 0.988 atmospheres. What is the temperature? 25 degrees Celsius. Notice we also know our R value because our R value is always 0.0821 liter atmospheres mole Kelvin. Now, we have to figure out what to do about these 2.34 grams. 2.34 grams does not represent moles, but it's a cousin to moles, and it's something that we can still figure out. So we're going to go ahead and take a look at our reference sheet here, and this has been cut off at the top because we're only focusing on mass, moles, number of particles, and gas volume at STP for the first semester. We were given a mass, and our goal is to convert that into moles. We're going to do that by following the arrow. And the arrow, when I move from left to right, tells me that this is the railroad track conversion that I need. 1 mole on top and X number of grams on the bottom. So 2.34 grams of carbon dioxide. Now, carbon dioxide is a compound. And when we look up on the periodic table, we're not going to see the individual gas carbon dioxide, but we're moving into this anyway. Carbon dioxide is made up of 1 carbon, and it's made up of 2 oxygen atoms. From the periodic table, carbon has a mass of 12 grams, and oxygen has a mass of 16 grams. But there are a total of 2 oxygens, so when I multiply this by 2, I actually get 32 grams here And as we know, there's only one carbon, so I still have 12 grams here. When I add these up together, I get a total of 44 grams total. And that's going to represent my molar mass from the periodic table, specifically the mass of CO2. So I know that there are 44 grams of carbon dioxide for every 1 mole of carbon dioxide. Notice I'm labeling my unit, which is grams, as well as my substance, which is carbon dioxide. If I've set this up correctly, these will cancel. And the only thing I need to put into my calculator would be the 2.34 and the 44. Calculator, 2.34 divided by 44. So go ahead and do that into your calculator. 0.05318, and it keeps on going. Moles of CO2. Now, at this point, you can leave it with all of these digits. That's fine. You could even keep it into your calculator. You could round, although rounding could potentially lead us to some error. I'm going to go ahead and I'm going to leave it as 0.05318 when I work through the problem, because I don't need to round yet because, again, I'm not at the end of my problem. So we don't want to add error into our calculations because we want to have the most accurate answer possible. We said that our pressure was 0.988 atm. And we said that our volume is what we're looking for. It is our X. N we found out to be was 0.05318. And again, that number kept going if you're keeping it into your calculator. R, of course, is always 0.0821 liter atmospheres mole Kelvin. And finally, temperature is 25 degrees Celsius. Now, 25.0 degrees Celsius plus 273 is 298 Kelvin. So when I go to set this up, again, same thing like I did before, PV equals nRT. It's important I'm solving for the correct variable and that I show my work. So volume is my unknown. I'm going to divide through by pressure so that I have volume by itself. Pressure cancels. So volume is equal to nRT divided by P. When I substitute this in, I get 0.05318 moles. And again, that number may keep going in your calculator. 0.0821 liter atmospheres mole Kelvin. And then finally, my temperature of 298 Kelvin over the pressure, which is 0.988 atm. So in my calculator, I'm going to have this value for moles, my R value, my temperature, and then I'm going to divide through by my pressure. Go ahead and do that calculation, and let's see if you get the correct answer. 0.31689, and it keeps on going. If I go back to my original values, I was given 3 sig figs across the board. So if I look at my first 3 digits, 1, 3, and 1, I do have a 6, which tells me I need to round up. So my final answer is 1.32. And then my volume. What is my unit for volume? Well, if you're not sure, you should be able to show the cancellations. Moles cancel, atmospheres cancel, Kelvin cancels. The only thing I left is liters, which is the correct unit for volume. So my final answer is 1.32 liters.